In chapter 2, section 2, or 2b rather, we started talking about domain, and we were able to start to analyze what the domain of a function might be based on ordered pairs, or possibly even based on equations or expressions. Now we're going to start talking about the domain and other things, but we're going to get this information off of graphs. So if you're looking for the domain or range from a graph, remember that the domain, once again, as we've discussed, the domain deals with all the x values. So you're going to move from left to right, and you're going to identify all the x values that are represented in the graph from left to right. The range, that refers to all the y values from the bottom to the top. Again, all the values from the bottom to the top. So again, these are x values represented in the graph. I mean, that kind of looks like a y. So all the x values and all the y values. The answers for this is going to be in interval notation. And remember that a solid dot, or what we're really talking about, is a closed circle at the end. The closed circle represents brackets because it represents equals, okay? And the open dots, or open circles, right? They get parentheses because that means not equal to. Okay, closed circle is equal to, and this is not equal to. Okay, and so again, we know open and closed circles, and we know parentheses and brackets. The other thing we're going to talk about is where a graph is increasing and where a graph is decreasing and where it is potentially constant. And again, to do this, we have to look at a graph from left to right, okay? So if I'm moving from left to right and the graph is rising, then it is an increasing graph. And rising would be something like that. It might be a line, it might be an arch, but it's definitely going up from left to right. Decreasing means that as I'm going from left to right, the graph is decreasing. It's going down and to the right, okay? Constant means that as I go from left to right, there's no change at all. It's not going up or down, just right, okay? It's just going to the side. And again, my answer is going to be given in interval notation. Open dots is what you're going to use, except if the graph starts or stops at a constant. And again, I'll talk about that. So let's look here at drawing 1. Notice the instructions here want us to find the domain. They want us to find the range. They want us to find where the graph is increasing, decreasing, or constant. And all this information for each one is going to be given in the form of interval notation. So let's start with the domain. The domain is going to refer to my x values. We know that. So in here, if I notice, I just start moving from left to right. Let me see if I get right here. I'm going to move from left to right, and as soon as I identify the first x value, okay, notice that these are my x values, -3, and stuff like that. Okay, so this is my x-axis, and so I'm going to go along this x-axis until I find my first point, and I notice that my graph will start at -3. It's an open circle, so it's not including -3, but I know my domain is going to start at -3, and it's going to move along all the way to here to x is 0, okay? Not negative infinity, sorry. -3 to x is 0. And notice that at x is 0, it's a closed circle. So I just represented the domain of this piece of the graph. Notice this is also a piecewise graph. This is a graph that is a line here and a parabola here. And again, we're not going to graph any of these just yet. We just have to know how to pick out the domain from it. So again, my first x value left to right is -3, and I go x is -2, -1, 0, and then my x's stop for a bit, okay? Then all of a sudden, I notice that, again, I find another point up here where x is 2, and then notice it goes up, and this is really going to go up to infinity, really like forever. It's going to go to the right like that, right? And so that, I know that's going to go on forever. So as soon as I get to this x value of 2, I know that all the other x values on this line are going to have a y value associated with them. Yes, it might be way up here, it might even be off my page, but it's going to be there. So I know that I start back up at 2, and I'm going to go to infinity. And so this is my domain, -3 to 0, and then 2 to infinity. And again, remember, these are all dealing with my x values. My range is going to do the same thing. I'm going to start from the bottom up. I'm just going to do, these are my y values. So I have to find the minimum y value represented, okay? And that's going to be 0. Notice this ordered pair right here would be -3, 0, okay? The y value is 0. That's the lowest point on this graph. So I know that my range is going to start at 0. Okay, it's not going to include 0. It's an open circle. So I'm going to go 0, 1, and then notice that I go to 2 here. So I know that this is going to go to 2, and it's going to include 2 because it's a closed circle. And then union, and then I've got to see where it picks up. So again, I go 0, 1, 2, nothing here. When I get to 3, I notice there's an x value here that has 3, and then, a y value, right? This is 2, 3, so there's a y value here, and then it goes up to infinity. So I know that after 2, the next y value represented on this graph is this point right here, 2, 3. So it's going to be open circle at 3, and then it goes up to infinity. And so that's the range of this drawing. And by range, again, I mean the y values represented in this drawing. Okay? Again, you can think of it as this way. Think of this graph. These are my y values in this picture, from 0 to 2, and then up to infinity, from 3 up to infinity. And so that's what I'm depicting here. Okay? So now that I did my domain and range, I'm ready to talk about where my graph might be increasing and where it's decreasing. And again, remember that as you move from left to right, if your graph is going up, as is this is an increasing piece of the graph. Then I notice that I keep going over here to the right, and notice that as I move to the right, my graph is going higher and higher. So again, this is also increasing. So the values I'm going to use are the ones from the domain. The only difference is that when I write that it's increasing or decreasing, I don't use brackets at all. So it's going to be, it's increasing from -3 to 0, and it's increasing from 2 to infinity. I don't need to put the union there, and I don't need to put the parentheses. But those are the two parts where it's increasing. And then decreasing, it's not decreasing at all or constant in this picture. So that's pretty much done. Now, again, I'll go to the next one, and I start asking myself, well, let's see. My domain. As I move from left to right, I notice that this thing here, this point, I know it looks like it goes straight down, but that's not really how that's really a piece of a parabola. It really, just think of it as it goes out forever and ever and ever. So notice that my graph is really going to infinity on the left. And so I know my graph is going to start, my domain is going to start at -infinity. And as I move to the right, all these x values are going to be represented again. If x is -10, there's a y somewhere down here. I move all the way to the right, and it stops at -2. The x's stop at -2, and it's an open circle. And then my x's pick back up again here at x is 1. And notice it's a closed circle. So x is 1. And then it ends, my x's stop again here at 2. And so my last x is 2, and it's an open circle, so it's a parentheses. So my domain is going to be -infinity to -2, and then union, and then 1 to 2. Okay? My range, which we've already discussed, I know my range deals with my y values. And again, I know that this point, this line here, this, not line, but this left side is going to go down forever. And so I know that this is going to go from negative infinity up to something, right? So it's always bottom up, it's left right on the x-axis, and it's bottom up on the y-axis. So I know that it's going to start with negative infinity, and it's going to go up to this y value here. Well, when you're on the x-axis, the y value is 0, okay? And then after I go up to 0, I'm going to go, there's nothing, 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 and then at y is 1, I have a value right there. So y is 1, and then notice that it stops at 2, and it's an open circle. So it's very similar to the domain, but again, totally different things. Numbers might be similar, but it's different. It's the y values that are represented in this graph, okay? And then lastly, I'm going to go to the increasing and decreasing, and I know that this one, as I go through my x's, because remember, I have to say, as I'm moving from left to right along the x-axis, what's happening with the graph. So I know that this one, as I move from left to right, is increasing, as is this one. So I'm basically going to be rewriting pretty much the domain, okay? Whether it's increasing or decreasing, except I'm going to be using parentheses. So it's increasing from negative infinity to negative 2. You know, negative infinity this way to negative 2. And then it's going to be increasing from x is 1 to x is 2, right, where it stopped. And everything gets a parentheses. And so now let's look at the last one. I like the last one the best because the last one is representative of everything, okay? If I look at my domain and I think of, okay, what's the domain? I have 3 different graphs here. You know, we've got this parabola that's going to go that way. Let me just kind of do it bigger. I mean, I know it's there, but just think of it as something that goes on forever that way. This is something that goes on forever that way, and this one's a constant in the middle. So I know as I move from left to right, if I start over here, I know that way over here, there's going to be a y value up here. The closer I get, obviously it comes down, but basically there's going to be, for every x in this area, there's going to be a y value until I get to negative 3. That's where this piece stops. And so I know that my domain is going to be negative infinity to negative 3. Then the next stage, I'm going to start, the next x value represented in this graph is at negative 2. But because it's a solid circle, it's going to get a bracket. And then I keep going from left to right all the way to here, which is 1. And I see that I'm going to stop at 1. And then I keep going from left to right, keep going. And then again, my graph starts up here again. That's at x is 3. And it's going to go to infinity. And so that's my domain right there. Negative infinity. So my x values are going to go from, again, from negative infinity to negative 3. Then it's going to go from 2 to 1. And then it's going to go from 3 to infinity. And that's what I represented here. The next one, I'm going to do my range. And again, remember my range are my y values. And I'm going to start from the bottom up. Well, the very first y value that I have in this graph is a y is 1. And then after this, right, this one here goes from y of 1 to infinity. So pretty much I'm done at that point. It's going to be my first value is, and it's going to be equal to 1, right, because it's solid there. So I'm going to have a y value of 1 all the way to positive infinity. Once I get to this 1 value, then I have a y value at every other number. And then lastly, where my graph is increasing, decreasing, or constant. And again, I notice as I move from left to right, this is decreasing. So for finally, we have one that is decreasing. This is a constant. Notice it's not going up or down. And this one is increasing. So again here, when I write these, increasing, I'm going to match what I wrote for this section in my domain. In this section in my domain, it was x is 3 to infinity, so this is 3 to infinity, all with parentheses. My constant, right, is going to be this part of my domain, so negative 2 to 1. And my decreasing, right, is going to be the very first part of my domain, so negative infinity to negative 3. That looks like negative 8, sorry. Negative infinity to negative 3. All of these are going to come from somewhere in the domain, okay? It's just that these are always going to have parentheses. These are not going to have brackets, okay, ever, with increasing, decreasing, and constant. Again, I come over to here and they're asking me to do the same thing. They're telling me to find the domain, the range, increasing and decreasing behavior, then evaluate the function at the indicated value. So again, this is a piecewise function, and notice what this is telling me. It's telling me that when x is here, when x is less than or equal to 0, it's this line, okay? And then when x is greater than 0, or actually even greater than 1, right, we're going to use this line, or this parabola. So again, it's just showing us kind of where the border is there. Again, let's just find the domain and range and all that. So again, my domain, at this point, I think you get the hint now. You're going from left to right. And this domain at x is negative 2. Then it moves over to here until x is 0 and it's equal to 0 because it's a closed circle. And then I have, again, it moves over to 1. And then I know that this goes to infinity. And so that's my domain, okay? My range is going to be my y values. And again, my lowest point on my graph is at negative 4, and it's including negative 4. And it goes up to, it really goes up to infinity from that point. Okay, there's a y value for every other point above negative 4. And so that's my range. I know this is decreasing. I know this one is increasing. So again, I go increasing, right? And it's increasing on this one, which is 1 to infinity. And it's decreasing at this one, which is negative 2 to 0. Okay? And so that's the decreasing part. The last part of this problem is to find the value. So what is the value of the function at x is 0? So just go to the graph, and when x is 0, what is the y value? It's right there. So 0, negative 4. So when x is 0, the input is 0, the output is negative 4, and that's how you get that ordered pair, okay? When f of 3, that is, what is the value of the function when x is 3? Well, when x is 3, it appears that y equals 0. So 3, 0 is the point, and that kind of gives me the values, okay? And that's it for that. So we go to the next one, and you see this parabola that goes through 0.01. And what you notice is there's two sides here. This side here is decreasing. This side here is increasing. Let's try to do our domain. Again, notice that my graph, if I go from left to right, this is going to go forever. So I know that there's, if I'm way out here, I'm going to have a y value up there. So I'm going to have values on this graph everywhere. So this graph really goes from negative infinity to 0 here, including 0. And then it goes from 0 to positive infinity. So this is really all real numbers. This is negative infinity to positive infinity. My range, again, I'm going to start at from bottom up, and I'm going to identify my very first y value. When I go up here, I see it right here. That's the vertex of this little parabola. That y value is 1. And then after that, my graph goes up to infinity. So that's my range. my graph is decreasing. Let me start with increasing, right? It's increasing on this right side from 0 to infinity, okay? So this one's a little bit different than the domain. It doesn't exactly match it. And it's decreasing, okay? And 0 is included, actually. It's in, oh, no. And increasing and decreasing, we don't do brackets. Sorry about that. So from 0 to infinity. And then this one is decreasing from negative infinity to 0. Okay, so it's domain range, increasing and decreasing. And then f of 0, what is the value of the function when x is 0? It is 1. Notice this ordered pair here at 0, 1. Okay, so when my input is 0, my output is 1. Okay, and then lastly, this last drawing here, where we have, again, another piecewise function. So my domain at this point is going to be, I'm going to start here. This is -5. That's my x value there. And then I keep going all the way to here, which is -3. And it's a bracket because it's a closed circle. Then I keep going, and I get to here, -1. And it's an open circle. And it keeps going all the way to x is 1. And it's a bracket. Union. And then from here, I keep going to here, which is 3. And it's an open circle. And then notice that this is going to go really to negative infinity. Or to positive infinity, rather. And so this is infinity, like that. So again, my domain for this is -5 to -3. Then I get union, -1 to 1, union, and then 3 to infinity. My range, these are my y values. Again, I have to start bottom up. Notice this goes down to negative infinity, so I know negative infinity. And then I'm going to go up to negative infinity. I go up over here to 1, and then this one keeps going, and then this is the highest point of my graph, which is +3, and it's an open circle, so it's a parentheses, and there's my range. Now this is decreasing, this is increasing, and this is decreasing. So when I write these, my graph is increasing, again, from -1 to 1 for my x's, and it is decreasing, right? It is decreasing from -5 to -3, and it's decreasing from 3 to infinity, okay? And that's how you write these also. And then again, the values. So when x is -3, the y value is 1. So when my input is -3, the output is 1. That's what that equals, okay? And then last but not least, let me just erase all this. Last but not least, when x is 1, right, my y value is also 1. And so when my input is 1, my output is 1. And that's how we solve these problems. Okay, now we're going to get to even and odd functions. And even and odd functions are really telling and helpful down the road when we get to graphing, okay? Now, a function is considered an even function when you replace x with -x, and yet you still get the answer that you started with, okay? So you plug in -x, and when you do the work, you end up with the original f of x, or the negative part just goes away, okay? And when you have an even function, when you find out that a function is even, what that means is your function is going to be symmetric to the y-axis. We'll talk about that as we go on. An odd function is a function where if you plug in the -x, your output is going to be the opposite of f of x. In other words, if your x changes to opposite x, that's your input, the opposite of x, you're going to get an output of the opposite of y. Basically, all the values, all the terms will flip signs in the new one. And again, I'll show you what I mean, okay? But each term will change signs, and that means that your graph is going to be symmetric to the origin. And then the last one is what you would get with x-axis symmetry, right? When y is raised to an even power, or in an absolute value, we talked about this already a little bit, then a function cannot have x-axis symmetry, okay? We'll talk about that a little bit more, okay? So right now we're really talking symmetric to the x-axis. We're talking about symmetric to the origin, and we're talking about some exceptions here about x-axis symmetry. So if I come over to here, it says determine if the function is even, odd, or neither, and we'll talk about what we do. So remember that if we want to know if it's even, what we're going to do is we're going to replace x with negative x. And so we come over to here and we're like, okay, the opposite of x cubed minus the opposite of x, like that. We're replacing all the x's with negative x. When I do that, I get minus x cubed plus x. Notice here that my original x cubed was positive, now it's negative. My original x was negative, now it's positive. All my signs changed. Because of that, I know that this is an odd function, okay? And because it's odd, I know it's going to be symmetric to the origin. Let's go to the next one. So again here, I'm going to make it negative x. I'm going to come here, minus x squared plus 1. Minus x squared is x squared plus 1. Notice this and this are the same. F of x and f of negative x gave me the same output. So this is an even function, and I know that it is symmetric to the y-axis. I come over to number 9, and I plug in the opposite of x, 5 minus 3 times the opposite of x, and I'm going to get 5 plus 3x. Now notice this one. It's not the same as the original f of x, so it's not even. Both signs didn't change. If it was odd, my 5 would become negative and my negative 3x would be positive 3x. Only one thing happened. So this is neither even nor odd, okay? Which means it's not going to be symmetric to the y-axis, and it's not going to be symmetric to the origin. Okay, so here it says determine if the function is even, odd, or neither, then determine if it has symmetry. So again, I come over to here and I see x to the 4th. When I see these even powers, pretty confident that this is going to be even, but again, you want to always double check. So I'm going to do negative x to the 4th minus negative x squared minus 1. Notice I'm going to get x to the 4th minus x squared minus 1. It's going to be the same, right? Which means it's going to be an even function, and it's going to be symmetric to the y-axis. Okay. When I come over to the next one, again, I do my f of negative x, 2 times negative x cubed plus 3 times negative x. And this ends up being negative 2x cubed minus 3x. Notice that this changed to negative and this changed to negative. So this is an odd function, right? Which means it's symmetric to the origin. Okay. Then last we get to these examples here on zeros of a function. The zeros of a function, guys, these are your x-intercepts. We've talked about these. These are your zeros. These are your solutions. And this is what we've done a million times. Whenever we have a function, we set it equal to 0, and we solve. Okay? We solve and we find the values of x that make the output 0, and those are our famous intercepts and things like that. So when I come to this problem and it says find the zeros, I'm going to make this, remember this is like y equals 2x squared minus 3x plus 1, which really is finding the zeros is making the y equal to 0. So it's just 0 equals 2x squared minus 3x plus 1. Well, how did you guys do this before? Remember, you just solve the quadratic. So the product is 2, the sum is negative 3 minus 2 minus 1. So we get here 2x squared minus 2x minus 1x plus 1. Factor by grouping, right? 2x, x minus 1, minus 1, x minus 1. And we get our factors are x minus 1 and 2x minus 1. Remember here we set each factor equal to 0. So x is 1. And 2x minus 1 equals 0, 2x equals 1, x equals 1/2. You've been doing this all year. The only difference is when they say find the zeros, you can say x is 1 or 1/2, or you can write it as an ordered pair. If x is 1, remember your output, right? So if x is 1, y is 0. If x is 1/2, y is 0. So these are the zeros of the function, whether you write it like this or you write it as ordered pairs. Now here again, if I'm trying to solve this and I have this numerator and this denominator, again I'm going to do 0 equals 2x plus 5 over x plus 5. Now here, remember, I'm trying to find the x value that makes the output 0. So technically, as long as this numerator ends up equaling 0, my whole fraction equals 0. So I could just do 2x plus 5 equals 0 and solve for that. The other thing, I could just do it the long way. I could multiply both sides by x plus 5, right? Which is going to give me 0 here on the left and 2x plus 5 over here. So either way, whether I skip canceling the denominator or I just set the numerator equal to 0, I get the same result. I'm going to subtract 5 from both sides. Negative 5 equals 2x, divide by 2, and I get that x equals negative 5/2, which means either like that, or I could do this ordered pair. Either one, that's my 0, that's my x-intercept. That's the value of x that makes the function equal to 0.